Okay, we might make a start. I'm conscious of people taking time on a Wednesday evening. So good evening, everybody. My name is Shane Yule and I'm Vice Chair of Engineers Ireland West Region Committee. This webinar is the first of a series of CPD events organised by Engineers Ireland West Region Committee in relation to solving the challenges facing engineers today. And I think it's apt that the first webinar focuses on low carbon design and the climate emergency, which really is, I suppose, the greatest challenge facing engineers, but the whole of society today. The built environment sector accounts for 37% of Ireland's carbon emissions, which is of a similar scale to the emissions by the agricultural sector. Approximately 2/3 of these emissions come from operating buildings, and more than a third, 14%, comes from manufacture, transport, and installation of building materials themselves, usually referred to as embodied carbon. Therefore, the construction sector and the professions that work in the industry will have a significant role to help mitigate its effects. In 2021, the Irish government signed into law the Climate Action and Low Carbon Development Act, committing Ireland to 2030 and 2050 targets for reducing greenhouse gas emissions. So the country is now in a legally binding pact to net zero emissions no later than 2050, and a 51% reduction in emissions by the end of this decade. Tonight, we have three excellent speakers: Marion Jamet from the Irish Green Building Council, Cian McGuinness from the RPS Group, and Conor Hayes from Arup. So last year, the Irish Green Building Council published a roadmap to decarbonise Ireland's built environment across its whole life cycle. This roadmap provides all stakeholders in the built environment actions that one can implement across the life cycle of projects. And this evening, Marion is going to give an overview of the roadmap. And we will put that roadmap in the chat box for you to download following this webinar. And following Marion then, Conor and Cian are going to talk about strategies which they have implemented on projects to reduce their environmental impact. The format for this evening is that we'll have the three presentations first, followed by a Q&A session in which you can ask questions of our three speakers. So you can enter them in the chat box at the bottom of the screen. A recording of this presentation will also be made available on the engineers website at a later date. So Marion is responsible for Irish Green Building Council's policy and advocacy campaigns, including the Building Life campaign. As part of this work, she coordinated the development of the Building a Zero Carbon Ireland roadmap. Marion's working background is in stakeholder engagement, policy development, and project management, with previous roles in Dublin Chamber, Eurochambre, and European Parliament. Marion holds an MA in European Affairs from Sciences Po in France and an MSc in Environmental Sustainability from University College Dublin. So I'll hand you over to Marion.
Thank you, Shane, and good evening, everyone. I'm just going to try to share my screen now. Give me 2 seconds. Hi, good evening, everyone. I'm delighted to be with you this evening to give you an overview of the Building a Zero Carbon Island roadmap, which was developed by the IGBC over the last 18 months. What I would like to do today is really to give you kind of an highlight of some of the challenges that we are facing in the industry, and then focusing more specifically on some of the action that we can all take, I suppose, to decarbonize our built environment, with a specific focus on engineers and contractors. So for those of you who do not know us, just very briefly, the Irish Green Building Council is a non-for-profit membership organization. We currently have over 300 members, and we work together for a more sustainable built environment. So to do so, really, we have developed a number of training in terms of green building certification, life cycle assessment, indoor air quality, but we also developed a number of tools to support this transition, such as the Home Performance Index, which is a national certification for new residential development, and EPD Island, so that's Environmental Product Declaration Island, where you can find information on the environmental impact of various construction products. And another big part of our work is really much around advocacy. Now, let's look go back to the roadmap, which was launched at the end of 2022. So this was developed with support from the IKEA and Lodes Foundation. And it was done like through extensive stakeholder engagement. I think we had over 200 key stakeholders involved in this development over almost 18 months. And just that you know as well, to give you a bit of context, similar roadmaps were developed in 9 other European countries, and at European level, these 10 roadmaps are available on the World Green Building Council. So if you're interested in knowing as well what is happening in other jurisdictions or at European level, you can have a look at it. And really, the roadmap being the Irish roadmap or the European roadmap is very much informing all our work this year and most likely for the next few years. So just going back to the roadmap and what needs to happen. As highlighted by Shen, we have ambitious targets to reduce our emission by 51% by 2030 and to reach carbon neutrality by 2050. So the first thing we did when we decided, when we started working on that roadmap, we felt that we really needed to gain a better understanding of the emissions associated with construction and the built environment in Ireland. Because, yeah, we do have good data from the Environmental Protection Agency, but they very much focus on the operational emissions, so really the emissions associated with heating, cooling, lighting, or buildings. So really what we did first was to commission a piece of work from a group of researchers in UCD to Oliver Keenan and his team, and we asked them really to try to get a better picture of the emission associated with our sector. And as it has been highlighted by Shen, what that study shows is that emission from the construction and the built environment in Ireland currently account for about 37% of our national emissions, so the same as agriculture, so that's pretty significant. And about 2/3 of these emissions relate to operational energy, and 1/3 more or less to embodied carbon emission, which is kind of slightly higher than the average at European level, which would be closer to 11 or 12%. So really, what do we mean? What we have seen, like, I mean, over the last 20 years, let's say, is a strong focus on decreasing the operational emissions, so all the emissions associated with the use phase through NZEB legislation, for instance, but we haven't focused that much on emission associated with all the other stages of a building life cycle. So that's, and by that, you know, I mean extraction, manufacturing of materials, and construction of buildings themselves. So that's very much why we did try to develop this data to get a better understanding of the current situation. And when that was done, we did ask them to do some projection to 2030 and to some degree to 2050. This is always difficult as soon as you start doing projections, but the data that you have on that slide basically are based on existing policies, being, for instance, the Housing for All strategies, the Climate Action Plan, the National Development Plan, and so on. And you can find actually the full carbon modeling report is available as well on our website. But basically what that graph shows is that based on our existing policies, or operational emissions, so they are in green on the graph, should decrease significantly to 2030. So that's really if we meet all our renovation targets that are in the Climate Action Plan, and we all know, I think that's going to be challenging, but like if we do retrofit the 500,000 homes by 2030, and if we build a new building to the NZ standard and so on, our operational emission would decrease significantly to 2030. The problem here that we see is that you can see our embodied carbon emission in blue on the graph, which currently are not addressed, not really addressed as part of our policies or regulation, will keep increasing based on what we have said we are going to build in housing for in the National Development Plan and so on. So the challenge there is that really basically embodied carbon emission will increase in embodied carbon emission will counterbalance the decrease in operational emission, meaning that basically we cannot reach our 2030 targets if we don't start addressing both operational and embodied carbon emission. And talking with my colleagues, it's a trend that we see across Europe. Like some countries have started addressing embodied carbon emission, but they are not the majority. But overall, at European level, what we see is that just based on the existing policies and regulation, yes, our operational emissions should decrease significantly, but it's not possible to reach the 2030 target even at European level without addressing embodied carbon as well. So what we did once we had that data, we worked with this group of researchers in UCD to develop like scenarios, various scenarios that could allow us really to reach the 2030 target. And that's kind of what you can see on that slide, and you have more details in the actual roadmap. But just to keep it, I suppose, to a high level in terms of the recommendation that we have in the roadmap, and it has like something, I think, like 170 recommendation in total or something like that. But basically we have at a high level, we have tried to summarize our recommendation as follows. The first key action that we are mentioning is really the importance of prioritizing. So basically, okay, we need to build really to focus on all the things that we need really to meet our housing needs, our educational needs, and so on. But it might be the case that we may not be able to build absolutely everything within our carbon budget. So really it's about prioritizing what is being built, and that's one key message in the document. The second one is really around optimization, and by that it's about and actually, sorry, as well on prioritizing even before going there. Another way to look at that, it's not only at all the project, but it's also perhaps trying to better understand our needs and better taking them into account. Like we know that the average size of a home in Ireland is higher than at European level. We also know that the household size, are decreasing, and they will most likely keep decreasing. So perhaps it's time as well to start really looking at the type of housing stock that we need. Perhaps we have enough, like 3 or 4 bedrooms, semi-detached homes. So really this type of things, trying to look exactly at what is being built and what is needed. The second, high-level recommendation that we have is around optimizing. So it's about very much better using what we already have. So by that I mean, like, it can be, we know we have a high rate of vacancy, and that's something that has been often highlighted in the media, but it's not only about vacant home, it's also looking at buildings that may be underused. I know, like, the Heritage Council have very good quality data in terms of vacancy above the shop in some terms across Ireland. So that's the type of thing we need to look at, like, can we bring some of these properties back into use so that we can build less? Because again, like what the carbon modeling report show or estimate is that the embodied carbon emission of deep retrofit for a typical home in Ireland is about a quarter. So it's only two. The embodied carbon emission of a deep retrofit is 25% of the embodied carbon emission of a new home. So something that's really why we focus so much in the document on the importance of better using the existing stock and bringing back some of these properties into use. So perhaps that's the case that we don't need 400,000 new homes, but a part of these 400,000 homes could be delivered from the existing stock. But obviously, these properties, and I'm sure you all know that these properties need to be brought to a high to be more energy efficient, so they need to go through deep retrofit, and it needs to be quality retrofit. So you have quite a number of recommendations as well in the roadmap in terms of all these may be achieved, and I'm perfectly aware this is extremely challenging. And the third kind of high-level recommendation that we have in the document is really around reducing. So we are not saying that we shouldn't build anything. We are perfectly aware that we need new homes, we need new buildings. But what we are saying in the roadmap is that anything that is being built should not only be highly energy efficient, it should also be built in a more like eco-friendly way to reduce emission across the building whole life cycle. And I mean, there are two things that we need to look at there. I mean, the embodied emission of a building are a factor of two things. So the quantity of materials that we use and the carbon intensity of the material being used. So initially, really the first thing to do in terms of reducing this emission is looking at linear design, optimizing the form factor, and then obviously looking at materials with lower embedded carbon. It can be being like traditional material or more like bio-based material, or transitioning to a more like circular built environment. So that's kind of at high level that the three priorities that we have set in the roadmap. Now, I think you do have a link to the roadmap in the chat, but basically it's not, from our point of view, it's not good enough to make high-level policy recommendation. I think given the current situation, it's very important that we all act on that topic. So the roadmap is structured with specific recommendations for each sector. So this kind of a summary of recommendation for government, finance, the construction industry, and producers, with obviously, I think, for all like a strong focus on upskilling, and then trying very much to transition as quickly as possible to a net zero project, or for the industry or for producers to start to reduce, I suppose, the emission associated with the embodied carbon emissions, associated with their products. So that's kind of, again, at very high level, but then within the construction industry, you can see in the document, we have kind of a section and chapters for surveyors, for architects, for engineers, for contractors, for developers, and so on. So what I would like to do very briefly, and I would very much encourage you to have a look at the roadmap, but that's maybe just to give you an overview of the key actions that we are suggesting for structural engineers, mechanical engineers, and also for contractors. But I will encourage you to have a look at the roadmap. But basically, in terms of structural engineers, the first thing that we are saying in terms of key action that you can start taking in the next 2 to 3 years is very much about calculating the carbon impact of the different structural options. So obviously that means as well like upskilling on that topic, and also starting really to optimize, to optimize the structures, like to reduce material use, and as much as possible propose low carbon option where possible. And we have developed a number of tools to support you in that process, and training actually. But for instance, we did develop, with support from the LDA and the Land Development Agencies, a carbon designer tool for Ireland, which is a free tool that really allow you, like initially, I suppose, to have to calculate the embodied carbon emission associated with a project. It's not it's not one click NCA, it's not very refined, but it kind of gives you an overview at the beginning of a project. In terms of mechanical and electrical engineers, in terms of the top 2 like actions that we have recommended in the document, like to take in the next 3 years, is very much about focusing as much as possible on designing for performance and not just for compliance. And obviously designing for compliance, it's important. It's there for a reason. But if you look at the data published, for instance, from the CSO, the most recent data in terms of both building BOs and gas use, for instance, you clearly see that there is a performance gap, or perhaps more like a gap that is due to the design. So it's very important, I suppose, in our recommendation to design more for performance with dynamic simulation models where possible, and really much looking around like performance modeling. And also another thing that we are strongly calling for in the document is really for post-occupancy evaluation as much as possible, I suppose, to reiterate the process and improve over time. And the second high-level recommendation or action that we have in the document for M&E engineers is around very much collaboration and working in a more integrated way in the design team. And I think that's really something that basically, I think it's a recommendation that we have for all sectors in the roadmap. So better collaboration in the design team, but also with owners, facility managers, and so on where possible. And last thing that I wanted to share, is kind of in terms of more of the recommendation or key actions more than recommendation that we have for contractors in the roadmap. They are very much around upskilling all site personals in low energy construction, so being for contractors or subcontractors actually. And at the moment, I think like we see that the ETBs across the country are really are really like rolling out their NZEB training course. And it's fantastic, really. Like if we compare to where we were like 4 years ago, we have far more like training program available. But I think it's really important that we that as many people as possible, I suppose, complete this training. And the second action that we have is around like improving carbon reporting from site activities and gradually developing strategy for zero carbon site. And we have some very good case studies on our website on how this can be done, or it has been done, for instance, with good case study from Norway. So that it's not, but what I would like to say as well, this document was really produced like through extensive engagement with key stakeholders. We had a national technical leadership forum, which was helping us as well, developing all these recommendations. So we are not saying they are perfect, but what we were trying to do when we did develop the roadmap is making sure that we had key actions that everyone in the industry could start implementing. And the second part of that message from my point of view is that at the moment we are very much in the process of developing like a program to support everyone in the industry to implement these recommendations. So in simple word, I suppose my message is very much that we are here to help, and we have developed a number of tools, but we're also here to support people in starting implementing the roadmap. I hope I'm okay for time, but that's it. Thank you.
Thank you, Marianne. That's a great overview of the roadmap, and I think one of the useful things for anyone involved in the industry is the way it's divided for both design professionals, contractors, building owners, investors, and it gives actions that they can look at for the present day, 2023, 2025, and 2030. So it looks at short term, medium term, and long term. So thanks for that, Marianne. And as I said, the report, you'll find a link to it in the chat box. And if you wish to pose any questions, you can enter them in the Q&A there at the bottom of your screen. So our next speaker is Cian McGuinness from RPS Group. Cian is a chartered engineer with over 25 years experience in the planning, design and construction of major infrastructure projects in Ireland and abroad. He's a geotechnical director with RPS Consultant Engineers, responsible for the geotechnical elements of numerous highway, rail, energy infrastructure, water and wastewater and flood defence projects. In 2021, Cian was named by the Institution of Civil Engineers in the UK as one of its inaugural carbon champions. This recognised his efforts in quantifiably reducing the carbon impacts of infrastructure projects. He's a former chairman of Engineers Ireland West Region and a regular lecturer in civil engineering at University of Galway. So I'll hand you over to Cian.
Thank you, Shane. Hopefully my screen is showing correctly there and everybody can hear me.
Yeah, looking good.
Good stuff. What I'd like to do this evening is briefly bring people through a project that RPS worked on a couple of years ago, where we managed to achieve quite successfully a large carbon saving, and I suppose to some degree implemented the steps that Marianne described a little earlier. So the project in question was located near Glasgow International Airport. It was called the Glasgow Airport Investment Area, essentially a new manufacturing and innovation district was to be built within the curtilage of the airport. If you look on the little image on the right there, the main runway of the airport is just slightly to the right. So RPS were commissioned by Wills Brothers Civil Engineering to undertake the tender and detailed design of the civil engineering infrastructure elements of the project. They were mostly the roadways, bridges, water infrastructure and the like needed to service the development. So the project was probably one of the first that was delivered in accordance with the carbon standards PAS 2080. And the firm that had developed the concept design had also established a carbon baseline. So we had something to measure our performance against as we moved through the detailed design. The element in question, I suppose, it was related to where a road needed to be built over a buried electrical cable. So the image on the right there shows essentially the completed project crossing over a 132 kilovolt cable that's shown by the red line. Building a road over an electric cable is challenging at the best of times. This particular one was even more so. It was quite an old cable, dating I think from the 1960s. It was oil filled, as was the technology at the time. So you had liquid oil flowing in the cable. This, along with the age of the cable, it was close to 60 years old, meant that it was very vulnerable to any kind of movement or disturbance during construction. Damaging the cable would firstly potentially damage or disrupt electrical supply. This cable supplied over 20,000 homes. I think it also supplied the airport itself. Any damage to the cable would also result in a leak of the fluid from the cable into the environment. People may remember that was quite newsworthy a couple of years ago when some leaks from similar cables owned by the ESB came to light. So the owner of the cable was justifiably worried about the prospect of a road being built over the cable. They essentially said, don't touch it, don't go near it. They kind of said, look, don't even think about it, don't even talk about it. You know, they were worried that it wasn't in great condition even to begin with, and any kind of disturbance to it could have been very problematic. The potential problems really were that, I suppose, building a road embankment over the cable would inevitably cause settlement of the cable, which would strain it and potentially rupture it. And secondly, building an embankment over it would essentially bury it even deeper. These cables heat up the deeper they're buried, and the hotter that they get, the less electricity they can carry. So by burying a cable deeper, you will reduce its carrying capacity. And it was already at full capacity. The site was also tricky in that it was in a floodplain, quite close to a river, and it also was subjected to tidal flooding occasionally. So the concept design for crossing the cable is shown on the screen in front of me there. It's a fairly conventional reinforced concrete bridge where the cable would simply be isolated completely from the road. So we were looking at potentially roughly a 30-meter span using precast concrete beams. The ground was poor, so the bridge itself would have had to be piled. I think we were looking at piles 25 to 30 meters deep. We would also have a piled run-on slab to further minimize settlement. Again, piles likely to be 25 to 30 meters deep. So had we followed the concept design, we probably would have ended up with something a little like this bridge, which was a different bridge built on the same project, a conventional reinforced concrete bridge. So I suppose what's not to like about the conceptual design? In the context of today's lecture, I suppose, first thing was it had a very high embedded carbon, as is normal for most concrete structures. We were looking at an embedded carbon amount of over 1,500 tons. Separately, I suppose, we were quite worried about the prospect of doing a lot of piling in the vicinity of the cable, causing ground disturbance and vibration, and also bringing in heavy cranes and other heavy machinery into the general area. With the best will in the world, sometimes these things go wrong, and if anything did go wrong, the cable could have suffered for it. So we were very interested not only in reducing the embodied carbon of the structure, but also improving its buildability and reducing the risks to the cable. So the first thing we looked at was a variety of lightweight fills to see if we could reduce the settlement on the cable by simply reducing the weight of the embankment. We considered initially expanded polystyrene, which is a conventional enough material for that type of application. It's difficult to use in flood-prone areas in that it does have a tendency to float away. And we worked out we would have had to make it quite heavy in order to avoid floating away, and that would have essentially reduced the point of having a lightweight road. The other lightweight material that sprung to mind was expanded clay aggregates. These wouldn't be vulnerable to floating away, but in common with expanded polystyrene, one of their other uses is for insulation. So we would have spectacularly failed on the goal of trying to avoid the cable heating up even more. So we tried to think of what kind of lightweight material could we use that would be lightweight, would let water percolate through it, and would also let air pass through it to cool down the ground surface over the cable, and in turn prevent the cable from overheating itself. We kind of like the look of these kind of things. That I think Clint Eastwood used to blow them up in the westerns, but they didn't look very much like 21st century technology. But something like that would have worked quite well. We did then find the modern equivalent of that type of structure in a recycled plastic geocellular unit. Most people are aware of these things being used for underground storage tanks and attenuation facilities. We considered, well, could we use them to create a whole embankment that would be lightweight, that would let water through it, and would allow airflow over the ground surface above the cable to prevent the overheating. This would also be extremely low carbon compared to the large amounts of concrete that would be needed for the reinforced concrete bridge. So it seemed like a good idea, and working with the contractor and also in discussion with the cable owner and the local authority in Glasgow, we explored the idea. And this is the actual unit that we ended up using. It's a Waven Aquacell core unit designed for heavy duty applications, and critically is suitable for both regular and heavy traffic loadings, which was what we would need to support on our road. Not only did we, by using this material, we didn't need to go bring in heavy piling equipment or heavy cranes. And in fact, when working up close to the cable, we were able to bring in the material practically by hand. So any ground disturbance near the cable was reduced practically to zero. So this is what the cable crossing ended up looking like. You can see a ridge in the middle of the picture there. The cable is buried underneath that. And the black units are the geocellular units I mentioned. And the road will be built on top of those. So as I said, it prevented heavy duty piling, prevented cranes having to swing in heavy concrete beams and other heavy units. It kept a reasonable airflow in and around the cable to keep it cool. And because the crates or the units are essentially all air, the whole structure was extremely lightweight and prevented any settlement of the cable. So it's often said that, you know, you can have program, cost, or quality. You need to pick two out of those three. In this case, we wanted something that had less embodied carbon, that was low cost, that was safe to build, that was quick to build. And we didn't have to pick two out of those four. We managed to get all four of them with this particular design. This is the engineering drawing of the solution. So the kind of turquoise squares there are the geocellular units. They extend a little bit below ground to balance out the pavement on top in terms of settlement. We have a lightweight concrete slab directly under the road surface, and we use some lightweight expanded clay aggregates under the footways and to finish off the edges of the units, and wrap the whole thing up in fairly robust geotextiles to even out settlement as well. So I should have mentioned the key point maybe is that compared to the initial concept design of the reinforced concrete bridge, we achieved an 87% reduction in embodied carbon. This was obviously very significant in the context of this particular structure, but even when looking at the project as a whole, a lot of the embodied carbon for that particular project was in three particular structures, of which this was one. So getting an 87% reduction in one structure was significant even in the context of the project as a whole. We were conscious that we were using these units in a new way. They haven't been used to build an embankment before. And even the concept of crossing over buried electrical cables with them was quite new. So as you can imagine, we had to do a lot of validation prior to construction to ensure that it was going to work. We looked at the settlement using 3D finite element modeling of soil pressures. The heat dissipation calculations were done by our electrical engineers to verify that the cable would not get any hotter with this structure over it. We chose to get an independent category 3 geotechnical check of the design. And as a sort of final belt and braces, we put in a lot of instrumentation into the structure and on top of the cable itself to verify that we had successfully reduced settlement, that we had prevented the cable going into curvature and straining, and that the temperature inside the structure wasn't getting elevated. We've actually found that rather than settling with an embankment over it, the cable has actually gone up a few millimeters since the construction. So we're probably a little bit too successful. We overcooked it a little bit. I think the headline figure of an 87% carbon saving was very impressive, and we got a lot of very positive attention for it. As Shane mentioned, the Institution of Civil Engineers inaugurated the Carbon Champions program in 2021. And this was where they recognized projects and individuals who had delivered on large carbon savings. And the project team in Glasgow, RPS, Wills Brothers, the contractors, the cable owner and the client were included in that first list of champions. We also got awards from ACEI and Engineers Ireland for the project, and also a good write-up in the New Civil Engineer. So it's been, I think it was a very successful demonstration of how carbon savings can be achieved. And important to note that not only did we save carbon, but we got a lot of other positives out of thinking outside the box a little bit. I came across this headline actually when I was Googling on the project at the time, recording the fact that the world's biggest Lego bridge had arrived in Glasgow. I had thought that was further recognition for the project, given that the crates are not unlike Lego, but I was a bit disappointed to see that it was actually the suspension bridge on the right that they were getting excited about. Unfortunately, geotechnical engineers tend to bury their work, so they're not very visible to the public. That's it. The Engineers Ireland Engineering Excellence series that I mentioned produced a good video on the project. It's a 3-minute overview covering pretty much what I've talked about, and I think it's still available on YouTube if you just do a search for Glasgow Airport Investment Area. It's a good watch for a few minutes. Okay, I'll pass back to Shane. So thank you very much.
Thanks, Cian, for a nice description of a very novel solution to an unusual problem. And I'm sure the manufacturers of those the crates would be really looking forward if it could have the same impact in terms of Lego and same sales, but maybe not, because of as you said, a lot of geotechnical work is below ground. So again, just remind you, if you have any questions in relation to the presentation by Marion or Cian, you can enter them into the chat box or the Q&A at the bottom of your screen, and we'll address all questions at the end of the 3 presentations. So our final presentation tonight is from Conor Hayes in Arup. Conor is an associate and chartered structural engineer at Arup, working in the Ireland Buildings team. Conor completed his primary degree at University College Dublin and his master's degree at the University of Cambridge. He's developed a wide range of structural engineering, whole life cycle carbon and multidisciplinary design expertise over 15 years in the industry, working on complex architecturally significant construction projects. He is also Arup's Global Structural Sustainability Skills Manager, responsible for empowering the 2,000 structural engineers of the firm to make sustainability a normal part of the work that they do. So I'll hand you over to Conor.
Thanks, Shane. Yeah, so I'm a structural engineer, multi-disc PM, and a whole life cycle carbon consultant in Arup. My own journey in carbon sort of began as a young structural engineer around about 2009-10, because we seem to be specifying a huge amount of materials, and a lot of the projects were described as sustainable, but there didn't seem to be a huge amount of consideration given to material sustainability at project level. So I'm going to try weave a bit between Boland's Key, for which I was ARP's PM and lead structural engineer, and kind of the related topic of carbon. So some of this is about the project broadly, and then some of this is about Boland's Key, some of this is about carbon specifically. And that's kind of a key part of the point. I think what we're trying to do is trying to mainstream carbon as a normal part of the work we do, so that ultimately it's just an everyday thing that is just considered along with all the other design parameters and constraints we all have to consider day to day. And I guess as a slight tangent, I think picking up on one of the points in Marion's talk, we're working with a couple of contractors around, well, Dublin specifically at the moment, in terms of trying to measure the carbon emissions that they are responsible for on site, and to figure out the wastage that they're actually creating or not creating on site, so we can start better understanding the numbers that we're calculating when we do LCAs or life cycle assessments. So Boland's Key is an urban regeneration scheme which breathes new life into a formerly derelict industrial site. The restoration of 5 historic assets sits alongside 3 new landmark tapered towers over a 3-story basement. There's a new pedestrian bridge and 2 new plazas which link the campus into the local area. It was completed in 2022 and handed over to Google as an expansion of their EMEA headquarters. It will accommodate up to 2,500 workers across about 37,000 meters squared of net floor area of office, resi, retail, and cultural space. Google are currently fitting it out, and we're involved in part of that, adding some of the fine googly things that they like, such as link bridges, a gym, feature stairs, rooftop sports pitch, and so on. Are provided civil, structural, MEP, geotechnical, facades, traffic engineering, environmental consultancy, PSDP, and lighting services for the campus. As the PM, this stat sticks in my mind. 325 Europeans booked at least some time to the project across the duration of it, across 44 disciplines, some of which no longer exist in the current form, such as CAD. So given the audience, I should also be careful to celebrate the input of engineers across the project. The main contractor, enabling works contractor, specialist subcontractors, temporary works designers, the assigned certifier, the fire engineer, the monitoring team from AECOM specifically, the flood barrier specialist, and some of the engineers we dealt with in Dublin City Council as well. And it is, of course, a testament to the broader project team, architects, BKD, and so on. So I will talk a bit about, so that's just a side plan of the project. So looking at there, you can see the kind of 3 big blocks in the front are Tower 1, Tower 2, Tower 3, which are the prime new build aspects of the scheme. You'll see a small little block towards running along the bottom of your screen is Barrow Street. You'll see Building D, which was essentially 2 old houses which were retained. On the right hand side there was Building A and B, and Building B is essentially 5 buildings, B1 to B5. And then kind of facing onto the canal up at the top of the screen is the factory and Building C, also retained. And then sitting beneath that, you can kind of see we've drawn the outline of what is the basement. So there's a sometimes 2, sometimes 3-story basement that goes over much of the site, essentially stepping around either the quay walls or the listed buildings. So we didn't try to put a basement beneath the listed buildings or beneath the retained buildings, because they're not all listed. So there's some views of the structure of the towers. So essentially the new built towers, 2 of them were core RC core stabilized, with a composite steel frame, floor plates. So, you know, a fairly standard sort of a scheme for new build offices. You know, spans up to 18 meters by 7.5. The third tower is a 16-story resi, so Constance Class 3 RC frame. It is, you know, RC flat slab for the floor plates, and I guess notably for the structures, because the core was so slender, it's stabilized in large part by the perimeter walls, which are required to support the facade, but they don't go all the way down to ground, so you create sort of an outrigger effect with the perimeter columns. And there's lots of other, you know, lots of other features. The development targeted LEED Gold. It achieved a BER A3 standard. You can see on the top right cross section of the bridge, which was kept as simple as possible, driven tubular piles with a simple steel frame above. And that particular image is from a assessment of what happens if barges were to crash into it. The bottom left, on the left hand side, is some views of the facade. So there was quite a complicated desire for the facade. Multiple facade conditions were required to satisfy the intent, including vertical glazing, vertical terracotta cladding, vertical metal cladding, inclined glazing, inclined metal facades, incorporating cladding panels with vertical fins in flush glaze and frame aesthetic variations. So a bespoke project-specific unitized facade solution was developed that was capable of being modified to suit all the various facade conditions. This was factory assembled, brought to site, and craned into position, I guess, as part of the embodied carbon thing that helps to reduce waste. So the protruding feature aluminium fins were the only add-on for site installation, which minimized the requirement for a more traditional scaffolding approach. And again, like we won't get into great detail here because we want to move on to some of the carbon aspects, but there's, you know, the biggest challenge for the project was just the level of complexity. We're trying to do an awful lot of different things on that site when you're trying to retain the buildings and have different buildings with different uses and different structures and different MEP systems and so on. And the MEP system is flexible with a modular configuration, so it could all be treated as one or it could be split into the different buildings and operated separately. And one of the key decisions from a carbon perspective that were made early on in the process, and one of the key things we managed to persuade the architect to adopt, was to limit the glazing on the towers. So the opacity achieved 40% glazing, 6% opacity enabled an excellent energy performance without compromising daylighting values. And that's probably, you know, becoming more standard now. I think we're starting to move slowly away from the entirely glazed facades, but that, you know, that was a building that was being conceived in 2013 and 14, and so that helped future-proof the development in terms of its energy performance. The retained buildings then, the images you see there are from buildings A and B, but one of the really complicated things with the retained buildings was we were trying to do so many different things, and there was quite a lot of constraints in terms of where windows were, in terms of head heights that were available. So we've ended up with a whole series of different structures within them. So the retained buildings were refurbished to improve the structural condition and allow buildings to be repurposed for new uses. So we had to remove rotting timber inserts, corroding metal inserts, replace friable masonry, repoint, repair cracks. We repaired timber trusses, so we retained and repaired timber trusses. There was a specialist in Ballina who took the trusses away, and essentially you can see on the right hand side, you can see where the new bits of the timber essentially begin. We replaced gutters and flashings. We had to heat and dry existing walls at high moisture contents. And then kind of crucially for the future ownership of the development, we gave clear guidance on how those listed buildings would be monitored in the future and maintained in their current condition. And in terms of the new structure within them, we had new timber floors and refurbished cast iron columns, new RC concrete frames, composite concrete slabs and cellular steel beams. In some places we had slim deck floors, which are obviously quite a heavy embodied carbon solution, but the head heights are really, really tight. And we managed to incorporate ambitious MEP measures such that we achieved nearly NZEB building requirements in those listed buildings. So I'm going to move back onto the carbon as a topic. What you see on the screen there is from an optioneering study for another building we did in Dublin, which was simpler in that it's a single site. And we compared three options. One, a sort of simplistic do nothing, where you invested no embodied carbon, but you kept operating the building as you did, and due to the leaky facade, due to the the lower energy efficiency performance, due to the partial use of gas and so on, that's the green line on the bottom left chart, and that's the highest whole life cycle carbon. The next option was a demolish and rebuild. You get a far better operational performance, so that it was better than the do nothing, but that's the red line there, and that was the next best. Then we looked at a retain, refurbish, and extend option, where we infilled some atriums, we added 2 stories, we improved the facade, the MEP, and so on, and you still have an investment of embodied carbon, but a smaller one. And with the better operational performance, that blue line is by far and away the best whole life cycle carbon option for the project. So I guess what I'm sort of trying to introduce there is, on a single building, that's the typical answer we find when we look at them, which is that it's very hard to justify usually a demolish and rebuild as the best carbon answer by itself. So I'm gonna leave that thought hanging, and we'll move back onto the building. So the site has been in use as an industrial site since at least the 1830s. It was part of the Boland's Bakery, which was the largest bakery in the city. Effectively, that became merged with Jacobs to become Irish Biscuits, and slowly, I think by about 2000, the site was no longer in use. So in that time, a whole series of different buildings have been built from different eras, a series of 19th century warehouses and so on, a series of 1940s, 50s, 60s kind of silos and other bits and bobs, I think is probably a fair way of doing it. And, there was severe degradation, spalling of concrete, rotting of timber, and that was particularly so in the years between the end of use of the factory and when our development began. So the developers of the site had their loans had gone into NAMA. So our client on the project was the receiver Savills, with NAMA as funder, who progressed the scheme. So when you're faced with a project like that, it's much more complex answer in terms of embodied carbon. What do you do here? Just keeping everything as it is not a real option. So kind of taking 2 examples on that side, the blue is what has been, everything outlined in blue is what was retained, everything outlined in red is what was demolished. And I've taken 2 examples in terms of what was retained or not retained. So in terms of building C there, which is the blue shaded, that was not listed, so we could have demolished it on paper, but it was a fine 19th century warehouse. The inside was almost free of internal structure, so we had a pretty clear run at being able to make good use of it for space in the future. It wasn't in too bad a condition. I think the roof had to be, the walls had to be repaired and the roof had to be replaced, so we retained it. Building F there blocks up completely our, where we have our future route from MacMahon Bridge into the site. It was a large silo. It was very hard to accommodate into any modern use. It was the concrete and the rebar were degrading, and it was decided to demolish. There would have been a huge cost, and also a huge embodied carbon cost in trying to retain that building. And also you have to step back and say, what's the best use of the site? So I will pick up that point in 1 sec. Yeah. So one of the excellent things that has happened, I think, in recent times is the new Dublin development plan. It specifically talks about getting a justification in terms of embodied carbon for major demolish and refurbishment, or demolish and new build options. And that's something we were occasionally asked for by planners before, but is now something that's been asked for as a matter of right. But I think one of the important things to consider is it doesn't just ask for that justification of embodied carbon. It also looks for an intensification of use close to public transport. It also looks for, a dynamic city that's capable of attracting FDI investment. It's also looking to try achieve higher densities in a 15-minute city and so on. And so one of the big challenges for these urban regeneration schemes is trying to find a framework that we can live with, that Dublin City Council and similar authorities can live with, so that we can get the right balance here in terms of, the uses that a modern society needs and minimizing our carbon footprint. And so that's just a comparison in terms of the the substructure, superstructure, and facade for the new build and the refurb on the Boland's Quay site. So it is true in the end that the refurb buildings involved a lot less embodied carbon. Now, it's a slightly unfair example. One of the interesting things you'll see is that the superstructure was not far lower in terms of embodied carbon for the refurb compared to the new build. The biggest thing was the 3-story basement, and basements are a big embodied carbon cost, and I expect that we'll see them come increasingly under pressure as people are asked to justify why we need so many car parking spaces and why we need so much space beneath the ground when it involves, you know, seek and pile walls and liner walls and so on, and such a high embodied carbon cost. But also, you know, to feed into that wider point, the retained buildings that we've kept are excellent. They really add to the character of the site, but they aren't quite providing the same level of space that the new build are. So it's true, it's an embodied carbon saving per meter squared, but we do have to consider that some of those new buildings can provide the uses that we need. And so then this is one of the other kind of key points for engineers, I guess, on the call, is that building less or even building nothing is certainly not doing less or doing nothing. So on the left-hand side is just, you know, some of the images from the very complicated phased retention works that were done. So there was, you know, the stabilization of existing buildings, the specification of a monitoring regime. There was all the quite intensive site investigation to see what structures could be kept and couldn't be kept and what would have to be done with them and so on. On the right hand side is a slightly more modern example from the same project. We also formed a new common entrance into the adjacent basement. So we had to tie into the adjacent basement and do some works in their basement. Those images on the right hand side are just a few snapshots from the fun we had trying to justify and then upgrade the existing precast podium slab level for new loads, including fire tender access. So we spent a huge amount of time and effort on it. In the end, all it involved was scabbling the existing screed and adding a new 75mm depth of screed on top with some rebar, but it involved a lot of engineering effort to get there. And so with that, I think I'll close and hand back to Shane.